All right. So, continuing on through the pre-chapter, we're over halfway. We're moving right along. So, last time we were talking about factoring. So, looking here, especially factoring by grouping, this is when we have four or more terms. We're going to group the first two together and then the last two together. So, what could I pull out of this first one? Well, I could pull an x squared out, and I would have x plus 4 left over. Well, I could pull a plus 3 out of the second one, and I would have x plus 4 left over. Again, when you do this, you want to have what's in the parentheses be the same. If they're not, look for more to pull out. So that's my common factor that I'm going to move to the front. What's left is what's in front gets put into the second set here, and away we go. So, shifting gears to rational expressions. So, rational expression is just a quotient of two polynomials. So, a polynomial over a polynomial. So, all of these would be examples of rational expressions. We have polynomials on top, polynomials on the bottom. Now, with this, we have to look at, because there's x's on the bottom, we don't want to divide by 0. That's something we cannot do. So, we have to exclude whatever will make the bottom be 0 when there's an x down there. So like on this first one, it's as simple as, well, 2 minus 2 would give me 0, so I just have to exclude 2 from this one. Here, a little more complicated. This is the difference of squares, so we have to factor that out, and so then we get two different ones of a negative 1 and 1 that would cause these to be 0. Because here, if we put a negative 1 in, that causes it to be 0, and anything times 0 makes the whole bottom 0. Here, if we put 1 in, we get 0, and yada yada. So, when you do these, when you simplify these expressions, first thing you're going to do is factor the numerator and denominator completely. Before you cancel anything out, that's when you want to look for, what do I need to exclude? What are those restrictions to my domain? So, like, for example, is this. First thing I'm going to do is I'm going to factor the top. Well, I can pull an x squared out, and I would have x plus 1 left over. So the bottom already is factored. We can't take that down anymore. So at this point, I'm going to go, hey, x cannot be negative 1 in this case, because if x is negative 1, that'll make the bottom be 0. Once I have my exclusions, hey, that can cancel out, and I'm left with x squared. So that's as simplified as it gets. So this one here. Factor the top. Well, I'm going to go two sets of parentheses. X squared would go to x and x. 5 is a plus, so I look at the middle. Well, those are both pluses then. And factors of 5 that would add together to be 6 would be 1 and 5. Bottom now. Well, that's a difference of squares. So this would go to x plus 5, x minus 5. So now I go, okay, what are my exclusions? What can x not be? Well, x can be negative 5 here, and x can be 5 on this one here. Now that I have my exclusions, then I can go, okay, I have a plus 5, a plus 5. This simplifies to be x plus 1 over x minus 5. Right. Now, when it comes to multiplying these, so we can add them, subtract them, do all that. But the first thing we're going to look at here is multiplying these rational expressions. So, just like with simplifying, you want to factor all the numerator and denominators completely. So factor the top, factor the bottom. Pull out those exclusions, and then divide any numerators and denominators by any common factors. So we're going to cross those out. Then you multiply those remaining ones. So just like with fractions, we multiply the tops, we multiply the bottoms. We go straight across. So in this case, I'm going to look at factoring. Well, these first two are already factored. The x minus 7 over x minus 1. Here, though, x squared minus 1 is a difference of squares. So that goes to x plus 1, x minus 1. The bottom, I could pull a 3 out and have x minus 7. So, exclusions. What can x not be? Well, x cannot be 1 here, because that would be bad, and x cannot be 7 here, because that would make it 0 on the bottom. So now it can cancel. Well, I have x minus 7, x minus 7. x minus 1, x minus 1. I'm left with x plus 1 over 3. That's it. Now, when it comes to dividing, just like with fractions, we're going to leave, change, flip. So leave the first one alone, change this, and this is actually a division sign. Change this to divide, from divide to multiply, and then we flip over the second one. So we always, of course, need to factor them first. So factoring two sets of parentheses, I would get x and x. That's a minus, so one's plus, one's minus. Difference would be 4 for the negative, 2 for the plus because the middle is negative, or a minus. Bottom is difference of squares, so x plus 3, x minus 3. Now, I'm going to change this to times, and I'm going to flip this over to x plus 3 over x minus 4 because those are both factored out as far as they can go already. So it's at this point that I'm going to go, okay, what can x not be? Well, x cannot be a negative 3, x cannot be 3, and x cannot be 4 because that'll cause the issues. So then I can go through and go, okay, I have a plus 3 and a plus 3. I have a minus 4 and a minus 4. So the only thing left would be x plus 2 over x minus 3. And I'm done. So, not too bad multiplying and dividing rational expressions. Where it'll get a little challenging is with subtracting rational expressions, is you have to have common denominators. Now in this case, we have common denominators, so we're going to be good there. But if it's not, which we'll cover here in a little bit, then we'll have to find those common denominators before we add or subtract. So right now, common denominator of x squared minus 9. Top here I have 5 x's, and I take 4 x's away, I'm left with an x. If I have 1 minus a negative 2 would be plus 3. Now, before I cross anything out, again, I'm going to go, okay, what can this bottom be? Well, the bottom could be x plus 3, x minus 3, since it's a difference of squares. So x could not be my restrictions of 3 and negative 3. Now I can go, well, that cancels, and I'm left with 1 over x minus 3 as my final answer. Now, as far as when they are different denominators, remember, you're going to multiply basically the bottoms. You're going to find the factors that are different, multiply them all as 1. So if this one here was missing a d, it's got to be times the top by the same. If this one here was missing a b, the top has to be times by the same to get our numbers here. So for example, here, our common denominator, well, we're looking for what's in common with the bottom. Well, nothing's in common in this case. So it's just going to be 2x minus 3 times x plus 3. If there's nothing in common, you're just timesing what's different. Well, this first one is missing an x plus 3, so I'm going to have to times it by x plus 3. The second one is missing a 2x minus 3, so I'm going to have to times it by 2x minus 3. So this here I have to FOIL. X and x would make x squared. X and 3 would be plus 3x. 2 and x would be plus 2x. And then 2 and 3 would be plus 6. Now, the minus 4 would get distributed in as well. I'm going to extend this out. So, negative 4 times 2x would be a minus 8x. And negative 4 times the negative 3 would be a plus 12. And now I can put like terms together after I do my exclusion. So what can x not be? Well, x cannot be a negative 3. Here's a little more complicated. There's more than just, so there's just not an x here, we have a 2x. So the only thing you have to do is if I take 2x minus 3 and I set it equal to 0, then I can solve for, well, what x would make it 0? Well, if I add the 3 over, 2x would equal 3, and then I would divide by 2, so x would equal 3 halves. So 3 halves would make this first one be 0. So that's my other exclusion. So now simplifying, my bottom will stay the same. My top now, there's only 1x squared, so that I can write down. If I have 3x's plus 2x's, I'm up to 5x's, but if I take away 8, that's a minus 3x. The 12 would go with the 6, and make a plus 18. Now, something you should always check is, will this factor out? Well, I'd go x and x. The plus means these are both minus, so factors of 18 put together, could I get a 3? No, not anything of a whole number anyway. So nothing will factor or will cancel at the bottom, so this is as far as we have to take this. So don't forget about your exclusions, and this is our final. So here's kind of some directions. You want to factor each one completely when you're finding that least common denominator. You're going to list the factors of the first denominator and then add to the list any of the factors in the second denominator. So think you're writing down what they have in common and then you're adding in what's different. And then whatever you have to multiply by, whatever's different in each one, you'll multiply the top by to simplify that one out, and then you're ready to go. So here, all we're going to do is just find the least common denominator. We're actually not going to find, add, subtract, or simplify that way. We're just looking for the common denominator. So if I factor this one, this would go to x plus 3, x plus 3. This one here, I would be able to pull out a 5x, and we'd be left with x plus 3. So for a common denominator, we have x plus 3 and x plus 3, which they both have an x plus 3, and then this one has an extra one, so that's why we write it twice. This one then would have an extra 5x, which technically we would write at the front, but it's commutative, so we can write wherever, and then we would go, okay, this one was missing a 5x, so we would times by 5x. This one was missing an x plus 3, so we would times by that, and then that's how we would get the tops. Now, putting it all together. So again, the book gives you this list of kind of ways to go about it. I'm just going to show you to kind of simplify it a little bit instead of talking about it all. So I'll talk, I guess I should rephrase that. I'm going to talk about it while I show you how to go through it. So this first one here, we're going to factor the bottom. So this would go to x and x. It's a minus, so one's plus, one's minus. And so to get 2 here, we're going to have a plus 2 minus 1. Second one here, difference of squares. It's x plus 1, x minus 1. So as I go through, start with your common denominator. So common denominator would be x plus 2, x minus 1, which this one also has. But this one, what's different is it has an x plus 1 as well. So start with what they have the same, and then you're filling in what's different. So they both have an x minus 1. This needs an x plus 2. This one needs an x plus 1. That's how we get our new one. So this one here, this one's missing x plus 1, so we're going to times the top by that. This one's missing x plus 2, so we're going to times the top by that. So FOIL the first one here. X squared. X and x squared. X times 1 would be plus x. 3 times x would be plus 3x. And 3 times 1 would be plus 3. We're adding. So this is a positive 2, so we're just distributed it in. So plus 2x plus 4. And then we simplify. But before we do that, let's do what x cannot be. Well, x cannot be a negative 2. X cannot be 1. And x cannot be a negative 1. So now for simplifying, x plus 2, x minus 1, x plus 1. So denominator doesn't change. Top though, we would have x squared. X and 3x would be 4x, plus another 2x would be plus 6x. And then we have 3 plus 7, so plus 7. Now, if we check to make sure that the top won't factor, so x and x, 7 would only be 1 and 7. Well, if this is a plus, we look in the middle, that's a plus. So sum of 1 and 7 can't get 6, so this will not factor out nicely. So that's as far as we got to go. Now, we also have complex rational expressions, which is really complex fractions where we have fractions inside of fractions. So polynomial fractions inside of polynomial fractions. No, it sounds like a lot, really not that bad. So 2 ways we can do this is one is we can find the common denominator and then do division of leave change flip, and then I'll show you the easier way, or at least the easier way that I feel it is. So common denominator, well, they both need to be over 1 or over x. Well, this one already has it, so this one's good. This one would be 1 over 1, so to get x on the bottom, we'd have to take the top times x to make it x plus 1 over x. Bottom, same thing. We're going to have a denominator of x, since x is on the bottom. Second one has it. First one needs it. So we leave change flip. So x plus 1 over x times x over x minus 1. Well, that cancels, although technically x cannot be 0 and 1 before I cancel those. So we're left with x plus 1 over x minus 1. Now, another way that we can do this. So if we have 1 plus 1 over x, and then on the bottom 1 minus 1 over x, what I want to do is I want to get rid of this denominator by timesing by the denominator. So I'm going to take the top times x, the bottom times x. So x over x is 1, we can times by it, and it works. We're not changing its value. So when I distribute, x times 1 would give me x. X times 1 over x would be plus x over x. Here, distribute it in and get x minus x over x, which x over x is 1, so we get x plus 1 over x minus 1. And again, the exclusions here, well, it can't be 0, because that would cause issues there. And if I put 1 in here, 1 minus 1 over 1, again, that would be bad. So we get the same exclusions, same answer, 2 different ways to do it. To me, this is a little simpler, but whichever way works for you, please do so. Now, last couple things. So, we never want a square root in the denominator. So that's part of the issue here, but part of the issue is also that we have a fraction inside of a fraction. Either way, we have to get rid of this denominator here of square root of 9 minus x squared. So that's what we're going to times by. Okay. So the top, it would get distributed in. If I have square root of 9 minus, or square root times the square root and the inside's the same, let's just simplify it to that. The square root cancels and I have 9 minus x squared. And the second part, I'm going to have a square root of 9 minus x squared over 9 minus x squared, which will cancel out, and it's just plus x squared. From there, the bottom here, I want you to think of this as to the first power. This right here, I want you to think of it as 9 minus x squared to the 1/2 power. Reason why is if we have the same base, all we have to do is add the exponents, and this bottom will be 9 minus x squared to the 3/2. 1/2 and 1 make 3/2. Now, the top can simplify, the x's can cancel, so we're going to be left with 9 over 9 minus x squared to the 3/2. All right. Now, as far as exclusions go, I totally missed that part. So technically on the bottom is if we have 3 or negative 3, that would be bad. And that would cover, we don't, well, same thing here. 3 or negative 3 would cause that to be 0, which would be bad. So those would be our exclusions on that one. Now, generally what we do is we rationalize the denominator to get rid of that square root on the bottom. We can also go backwards with it. In case we need to, for solving, we need to get things rearranged so that things cancel. Sometimes we have to rationalize the numerator. So, just like with rationalizing the denominator, we're going to times by its conjugate of square root of x plus h plus square root of x. So square root of x plus h plus square root of x. Well, what's going to happen here? Well, the bottom is going to be h parentheses square root of x plus h plus the square root of x. And I'm going to show you why I'm going to leave it like that and not distribute an h in. Top-wise, we would take the first times each other and the square roots would cancel and we get x plus h. Because these are opposite signs, the middles are going to cancel. So we're not even going to worry about those. So all we got to do is the last part here of square root of x times square root of x, which would be a minus x. Well, hey, guess what? Those x's cancel. We're left with an h. And that cancels. And we're left with 1 over the square root of x plus h plus square root of x. And that's it. That's this lesson. So, questions, comments, concerns, pan me, email me, send me a message on Google Classroom. Any of that works. Remember, you can always pause if you need time to write stuff down. You can always rewind if you need to hear something again. Otherwise, until next time, we'll talk to you later.